Ladies and gentlemen, hello, good day, and welcome to Dr. Plurings Computer / Electronics Laboratorium / whatever it is that goes on. Cheers on you. It is Friday, at least as I'm here and now. It is Friday. I don't know whatever it is where you are, when you are, rather. But right now it is Friday. And right here it is Friday, and I intend to finish this now. Finally, the third installment of the little relay box that has so far taken like 5 hours to get to this point where we are now. You could think that it should really not be that difficult and time consuming, but it turns out that it is, apparently. At least for me, at least under these circumstances. So, what do we have here so far? How far have we gotten on it? Well, we have all the high voltage things are connected like so. We have a power supply. Should probably be able to remove this clamp now, but the glue is not solid yet, so it still needs a while, I suppose, to fully cure. But we have all the high voltage connections should be done, and I have secured the outgoing cables from it, so that should not be possible to ruin unless you really want to ruin it. I still need to secure the incoming incoming high voltage to it, and I also need to secure down the various bus bars here. I think I'm going to actually just leave this exposed as is, the bus bars. Doesn't that sound dangerous? Yes, it does sound dangerous, but you're not supposed to open this unless you unplug it first. So I think it's fine. I mean, it's fine to have an enclosure with or a device with exposed high voltage in it. Most things that are high voltage, run on high voltage, do have exposed high voltage inside them, so I don't see the problem. And we need to make sure that this, for example, can't do that. Can't touch the ground thing, can't touch the live thing, because that would trip the earth fault ground breaker thing. And that this can't do that neither, because that would trip the breaker. Difference, of course, being that this would trip at about 37 milliamps. This would trip at about 10 amps, I think, depending on where I would plug it in. But yeah, you get the point. Oh, to secure these in place, I was thinking of simply drilling 2 holes and then putting a cable tie through and around. So say that the live bus bar we have that here, because that's where it seems to want. It seems that that's where it wants to be. So we drill 2 holes about there and there, I think. Yeah, I think so. This drill bit might be just a little bit on the large side. Don't wonder about. I want you here. That's one, and then see, we are approximately where I want it to be. Another one here. Like so. Lots of nasty plastics flying all over the place now. That got in my eye. Oh. Should I try not to swear in this one, maybe? What fucking difference does it make? None. Really. Maybe. I'm not sure. Yes. It's too late already then, if you don't want to swear. Okay, so you want this thing on the outside or the inside? It doesn't really matter now, does it? I will put it on the inside. And you want it, I actually want to go this way with it. Why? No, just because. Because I want to. That's how I want it. We really need this longer cable tie for this to accomplish now. We could probably get away with a very short one, but this is what we got now. I need to make sure that since we now have holes here, just where the live thing is, that there is absolutely no way that one could, but you can't, because you would need to have really small fingers to get inside there. And you could, I suppose, supposedly, you could take something that is conductive, like so, and push in here and touch that. But I mean, if you do that, you have yourself, yeah, sorry, but that's it for you. You shouldn't have done that. Pretty much. There you go. Live busbar is tied down and sort of securely in place. Neutral one. Bloody havet. I satan. I mean, there are a few sharp little cores of wires sticking out here from the busbar in a few different places. Should we do neutral and ground over here maybe? It would appear as though cable lengths and everything would allow it. These are the little cables that will go from the relay board to the microcontroller. I'll take them above the high voltage thing. So if we drill 3 holes here, should be able to do 2 cable ties, one for the neutral and one for ground or earth, right? Ground, earth, whatever. I'm probably going to have to be a little bit out of shot as usual. With this, because since I have the clamp there holding down the gluey thing, the power supply, I need to be out here doing this. So what we put one hole here. Yes, and I'm doing this carefully and slowly. That's why it's taking a long time, because when the hole, there you go, when the hole is finished, I don't want this thing to go all the way through and damage whatever it wants to damage on its way down. That's why I'm taking my time here, getting the holes through, and getting the drill to make the holes right. And another one. And whilst we're at this, like that for example, is what I don't want. Whilst we're at this drilling business, we might as well drill an attachment for the incoming high voltage thing, which will be about there. About there is where I have that. I'm going to have to go completely out of shot to this, but we can maybe bring this one around. Really, if it can be. There you go. Perhaps. Careful now here to not drill into any wiring. Why are you putting this so far in the thing? There is a good explanation. That's because this is this I'm out of shot. I'll explain later, maybe if I remember, which I rarely do. But it is my intention to explain all of this here at some point or other. There you go. See if we can get rid of all the crap. Now created a lot of microplastics here, or maybe this is not yet microplastics, but it will be one day. There you go. Try and get nasty. The little mouse has already fallen over. There you go. Try and keep it somewhat tidy. Don't want to end up like last time, being completely frustrated and sad about the state of things, not being able to think and so on. No, we want to avoid that if possible. There we go. Right, so we tightened this one. Yeah, the reason here that I wanted to explain then why this is so far in is because it comes in up here so it needs to come down before I can tighten it down. Right, it's clear, sure. There, see if we can get away with a shorter cable tie this time. Yeah, we definitely can. Come up here, find the hole. Find the hole. You usually have trouble finding the hole. Well, not usually, every now and then, but not often. There you go. Tighten it down securely, because this is actually quite important from an electrical safety standpoint. This can't be janked out. I mean, still, if you really wanted to, yes, you can, but by accident, it's not going to jank out. There, very good. So tighten it a little bit more, maybe. You can have a tool to tug on it. Maybe, and another tool to push down on the locking thing, such as a screwdriver flathead, preferably. Also, I had that just. This is quite familiar, isn't it? That Dr. Pluring had the tool in his hand just a moment ago, and now he doesn't know where he put it. Yeah, half the time that goes into all my projects goes to looking for tools, basically. There we go. That should be reasonably firmly locked in place by now. So, got the little end off there, and make sure we're not cutting anything else that we shouldn't be cutting. Oh, that's good. Very well done. Very well done. Now this fell over. Great. Yes, and my drink container is all twisted up in wires here. Let's not have it that way. No. Here's the microcontroller. Before we attach the microcontroller and install that, I'm going to tie this down then. If we do neutral down there, you could actually do this with one cable tie, couldn't you? You could come out and you could go back in, and you could come out again, yes, but then you need one more hole to do that. So that's what we're not going to do. There. High quality stuff, right? Yeah, damn Chinese mother. Try another one. See if this one is of any higher quality. I doubt it, because it's the same stuff. Cheap Chinese crap. That's all we have nowadays. Cheap Chinese crap. Yes, because it gets too expensive if you want to do it ourselves, apparently. So we get the Chinese to do it for best price. Best price culture. Yes. Never mind quality or working environment or ethics or anything like that, or what we do to the earth in the process. Never mind any of that stuff. Just best price, most profit in the short term. Not against profit or making money, but there's a difference in being profitable short term and making money short term, and being able to do that sustainably, not sustainably in these environmental people's sense of the term, because that's something different, but to sustain a profitable venture. And to make, oops, we're supposed to go inside here. Otherwise you're going to have a problem. There we go. Put that down there. That should be right, I would hope and think. Should have gotten a bit more pulley on this one in, but that's going to be difficult now. So there you have it. That's how it ended up. Why did you use these long ones here and the short? I don't know. There you go. That's all tied down. The relay board is sort of screwed in, more or less. The screws don't go all the way, because then they would be protruding out the back here. But it's sort of there. anyway. Right, and now we need power for the relay board before we do the microcontroller connection. So power for relay board, it needs 12 volts and it needs a ground. It technically may not actually need ground because it will ground through the microcontroller, but I'll put the ground in here anyway, just because, or for some other reason. For some reason we will do that. Yes, a little mouse where maybe you can observe things from over here. You were a little bit in the way, right there. Maybe. Hope you'll be happy there. You keep falling over. Yes. What about there? From there you have a good vantage point, I think. And from here we also need to go to the microcontroller then as a power supply for that, because that's what this is supposed to be. This doesn't really need to be this long. We can cut it about, doesn't need to be that long either. I'm making it now, but I always leave more than I need, things like that. And that will go into the microcontroller, and maybe you should just try and fit it in there first before you start cutting away too much. I did have a plan for how this was supposed to be in here. It was supposed to be in here like this, but then at that point the ground wire was not there. But we could maybe jam it in there. Yes, and then it will be held in place by sort of this neutral wire and the ground wire. Is that good? It would be preferable to have it held in by something a bit more secure maybe. But if you put the power connector underneath the incoming high voltage, if you were to do, it might not want to, not without breaking in something on the way in. Or if we make this a bit longer for just momentarily here. No, it's not going to fit, mate, because that cable is in the way. Okay, fine. What about that? Yes, that would work, but that's no better than you had previously, because this, I think this, as we had it from the beginning, and as it was also intended to go in from the absolute beginning, is still the best choice for this. Right. Yes, that wire is a bit dangerous because that is actually high voltage. There, going. Don't want that anywhere near that screw, but it's insulated. That's the problem. There is not really a problem. Just in case the insulation would come off and touch that screw, and that screw would have been screwed in a little bit further and protruding out the backside here. Yeah, it's neutral. It is neutral in case if you have plugged the plug in the right way around, or the correct way around. But if you plugged it in the other correct way around, then it could be live. Yes. There's already rambling and not getting very far or anywhere at all really on this. No? Yes, I am. We're making great progress here. Stop complaining and get on with it. Yes, I'm doing my best. This is a little bit difficult, and also this, I mean, it's not optimal. I would believe that the power cable here runs directly over, and it's almost in contact with the Wi-Fi antenna for the thing, right? I can't imagine that's the best way to do it, really. If we try turning it around and having it this way, what do you get then? And you actually get something that is not too bad, I don't think. No, that's quite alright, isn't it? Yes, that is quite alright. There, and you could even, yeah, you could put a screw or something there to hold it in place, sort of. Yes, I think that this is what we'll do. there, and then we see if we can we use this as a ground for the relay board. It is a bit short, but it is of a reasonable color. But yeah, it is a bit short. But there you go. Yeah, that's the way it will be. And also for the powering the thing, the microcontroller. That's this one. We'll make that about this length. There we go. Now I have spare wiring. Could be used for something one day, some different project. There, strip these back a bit. A length that is conducive to soldering them together here. There you go. Let's see here, this should be ground, and on this end, hello, on this end this should be ground. There you go, and that should be positive. Are you positive? I'm sort of, yes, reasonably. You use white for positive coming off the relay board, coming off, going into whatever. Really, no, this didn't. That one didn't really attach nicely there. No, this one is not the greatest. This purple one instead. See if that makes it better. No. Okay. Is there something the matter with the pin? Is it not up to spec? It's slightly too thin, maybe, or what? Because this one is much more firmly attached. Or it isn't, it's just that it is touching that thing. Okay, we use green. Green sounds good to me. Okay, I forgot to bring one thing or two here. I forgot to bring my assortment of heat shrinking. I'm on my way fetching those right here, right now. There we go. There we go, and then we just reattach the power supply to the audio recorder. There we go. Good. Yeah. Oh yeah. There we go. Okay. Right. Boom. So this ground, and ground. These three should all be joined together here. Right. There, and the purple one for positive was the one who went with, right? I believe so. We cut it about that length. Sure. Put that over there. Strip this back a bit as well. Maybe. Thank you. And some heat shrinking for this. It's relatively thin stuff. I would assume would do the trick. This might be just on the thin side. Let's see how it fits. Well, unless you make your solder blob too big, too thick, this will do just fine. We should not really need these long of them, but whatever. There you go. So we pull this apart a bit and put one on each. Make sure the colors are correct. Which one is the positive one? That should be that one. There you go. We split this a bit further so we can pull that back so it doesn't get shrunk onto the thing by the heat from soldering. There. Alright. Alright. There, and then we can make... we will start with the positive. Yes, we're positive today, aren't we? Sure we are. Always. Always with the positiveness. And positivity and so on. That's how you get ahead here in the life, by being and staying positive under all circumstances, no matter how bad it is. You should always pretend as though everything is great. Come on, man, don't get into this again. No, I'm really trying not to. Here we twist these together a little bit. Should you check the schematic to make sure that this is all that you intend to do here? I'm pretty sure that this is all I intend to do here. The schematic is underneath. I need to lift it all up if I want to look at it. Yeah, this is all that I want to do here. Should we verify that it is actually the positive? Yes, it should be. And on the other end as well, yes, and the purple one, that will be positive for the relays. Right, where is your solder? It's right here, it's behind the mouse. Okay, you get like a C for this. I mean, it will do the job, but it isn't beautiful by any means. Maybe we got it up to a B there, actually. Yeah, B minus, maybe. There, and we have this one, a negative for the DC power there, and negative for the DC power here. And then, I mean, after this, it's about done, actually. This is about the last... this is about the last soldering that should be necessary to get this thing on. Power it on and see if it works. Or if it will go up in a cloud of smoke. Yeah, I also need to connect all the wires to the actual microcontroller for controlling the relays, obviously. They are dangling loose over here right now. Yes, but that's not too difficult, sort of time consuming. Nothing here is too difficult, but it has proven to be very time consuming. There you go. Yeah, B plus again. Or B, previous one was B minus, this one is B plus. Except for that, you stupid fucking idiot. How do you expect your heat shrink to fit over that when you've done it this way around? It's not going to, it's not just going to go there, and that's about it. Should have put it on that end, or done this the other way around. Oh, for fuck's sake! There's only one thing for it, really, at this point. At this point there's only one thing for it, and that is to see if we can get these apart again. There you go. No harm done. Except for a bit of pride. There you go. These also need to come apart. I was just still stuck in the exact same spot. There you go. And these. Seriously, what sort of beginner's mistake was this? I think it's a result of me trying with the melted solder flicked away on my arm here. Oh, yeah, that burnt a bit. As I was saying, I think it's a result of me actually trying to speed things up a bit and going a bit quicker and so on. And there you go. That's the result of trying to be faster than what I actually am naturally. Make stupid mistakes. Have to do it again, and then it takes longer than it would have if you would just have calmed down and taken it easy from the first time around. Are you in a hurry or something? No. The people on YouTube seem to be in a hurry. The audience, they want short, succinct videos. Yes, but that's not what we do here. Again, and we don't need to go into this again. The first two parts of this here build has had plenty of that in them as it is, so we can skip that for now. This time, okay? Yes. Let's see, have we done this correctly? That should be negative. It seems to be negative. And since I'm holding on to the positive there, yes. Okay, solder them together here. There you go. I'm going to stop grading my soldering joints. I have stopped grading my soldering joints now. There you go. There you go. Are you cool enough to get the heat shrink over, and are you good enough to put the heat shrink over? Yes, you are good enough. This is actually negative. Yes, you already confirmed this like 3 times at least by now. Yeah, now you have the problem that it is not as slim as it was previously here, this solder joint, so you won't be able to get the heat shrink over it. Right, and we have alternatives to heat shrink, and that is electrical tape, and just doing that around the thing. Yes. Or another alternative is to try and make it a bit more compact by using like brute force. This heat shrink should fit over this joint. It just should. There, maybe? I don't know. No electrical tape needed. Nope. Good work. I have to say. Yeah, actually pretty decent. There, lighter. Yeah, sure. This is probably right. There you go, and then we take the red heat shrink and put that down over this one. There. Put that in the alligator clip, like so. We're just going to say what it is that you're doing as you're doing it. Yes, that's usually how it goes here. I don't know. And if you really wanted to, a YouTube video that tells you how to build a relay box, I'm sure that there are other creators that have made that for you in a much more digestible form. But if you want some company whilst you're doing your own, exactly like this, then you can follow along here in real time, and you can compete with me and see who's quicker and so on. Or compete, we don't need to compete. You can just do it for company, as I said. There you go. Yeah, again, sorry for blowing on the microphone and so on, but trying to protect myself from the lead fumes. Maybe the lead fumes is what got you me last time. No, it was the drive inspection thing. Oh, I don't want to think about that now. Let's not bring it up again. No. Okay, we need to put a bit of force on this as well and tighten it down a little bit. You know, if you would have made a correct solder, a nice job of the soldering from the beginning here, you would not need to do that. But it's all right. As long as this fits over now, which it did, it will hide all the mess that is underneath. There you go. Mess. I mean, it's not that bad. Where is it? You be the judge. You can sit there and be judgmental by yourself, or you can share your judgment in the comment section if you like. It's really all up to you. Apparently the green wire was the one you were supposed to use for positive, because that was on there, but there you go. The purple one was the one that didn't really quite... wasn't quite snug. There. No, it's not snug at all. See if we can modify that maybe a little by poking at it a little bit here. If we have something that is small and sharp enough to do that, such as the probe from the multimeter. Yeah, the problem with that is that this wants to go. This is not, you know, tight there. It wants to go up into the thing. Will that do it? Yes, no, it's worse now. It's actually worse now than it was before. Okay, see, can we pull this out of here and make it tighter maybe? Are you sure you want to do that? No, not in the slightest sure I want to do that. Can we... Because it's so very loose that I'm not quite trusting it. Since this needs to have power through it all the time to hold the relay. So if that glitches out, that will turn off the various equipment that could be on here. You see, that's how easy it comes out. Well, that's really no good then, if it comes out that easily. No, that's why you were supposed to use the green one, but now we are sort of kind of stuck in with this one, since it is solder and there's a heat shrink on it and everything. See if we can make this tighter somehow. And if we can operate on it, I think that the way you pull this out is actually this little tab. See if we can carefully pry that up. Yes, and then get this out maybe. Sort of, I got it up at least a bit. Yes, that's... What are you supposed to use for... Oops, I broke it, I think. There it is. Could leave it without this on. What purpose does that serve other than provide insulation? I think we leave it off and just try and tighten this up a little bit here carefully without tightening it, crushing it, that is, so that it won't fit at all. Yeah, no, that's firm, very good. And ground goes on there. There you go. We should now have power to the relays, and then we take this. You want to do a little cable zip tie around this maybe, just to have the appearance of being neat about it, at least to give that impression. I think so. I think I'm done soldering. I could turn the soldering iron off, but as you know, as I've said before, the rule is that if you turn off the soldering iron, it just has enough time to cool down before you realize that I actually needed to solder one more thing. So I'll leave it on until we're sort of done. There we go. Now these are the only ones that are remaining. The actual wires that do the thing, that controls the thing. There you go. Throw it away, and there, and I actually connected it to the correct pin right on the relay board. Yes, I did. because it has a JG VCC and it has a VCC. And VCC is the same as VCC coming to this side of the relay board. And these get delivered with a jumper pin there, connecting those together. And I managed to fry a microcontroller by putting 12 volts into it through that pin at one point. That's not recommended to do. Not this one, not in this build, but in a different build a while back. Yes. Where do you want this? I mean, there's a hole right there, but we couldn't. Could we get it so that you could screw it down into that hole? Oh my, that would be just lovely. We can try. I need to disconnect myself from that again to make my way over here and see if I can find a little screw for it. Yes, I'll be right back. I'm still with you here in an auditory sense. There we go. Let's see if we can find a screw of reasonable size and such as this one I think will do. There. And there. Should. Maybe. I think. Could work. Could not only work, it could actually be just perfect. Maybe. Perfect. But it's now in place. It's now held in place. So let's see what we have here. I think that the outer one would be ground again. May not quite be needed, this one, but still we're doing it. So we have, it's not entirely clear here to, what the hell is this supposed to be? That ought to be 3.3 volts, 5 volts and ground, and that should be voltage in, and ground should be, I think both of these are ground, actually both of them are ground. Yeah, I do believe. There, and then we should have the orange one, should be 3.3 volt. I believe, yes, VCC on the relay board. 3.3 volt here. There. These aren't really secure neither, but I hope it will be enough. That they're secure enough. They are secure enough, that is. Right, so now we have this. Number one. I need to look at here. Number one, GPIO 5D1. Number one. I need to look here is where I need to look. Number one goes to D1. And D1 is there. And yeah, it already came out. Great. Yeah, I mean it comes with it does come with these things. Something like this that you can put in and then solder on or whatever you want to do. But this will do, I would hope. We'll see if it will do or not. There, that was number one. And number two, purple one, yes. Number two is blue. And number two should go to D2, so that ought to be the one adjacent to the one that we just put in. It says so here on the board anyway. Then if that is the case or not, we will soon find out. And then the next one should be green, and that's number 3, and that should go to D5. So that should be there. I really don't like how loose these are, but yeah, it is what it is. Yellow in number 4 on the relay board, and that should be D6, so that ought to be there. There, that should be it. We should now be done with this. This should now be finished. Should we try it out? I think so, actually. If I did last time around, did all the high voltage stuff right, which I'm not entirely trusting that I did, considering how extremely tired I was at the time. I hopefully have not done anything too silly and stupid. But if I look at it like this, we can see that all the expected things, connections on the relay board actually are connected, and the other ones are not, so that should be good. And the The bus bar there you can't really go wrong with, except that it's maybe a bit ugly in places. And ground and neutral we have there, can't really go wrong with there neither. Right, okay, so we plug this in now. Yes, plug this in now. I already prepared that by bringing the cable over here. You look away, just in case it blows up a capacitor or something. It shouldn't, it really shouldn't, but just in case. See if the lights go out. There, it turned on. And apparently clicks the relays a few times as it boots up. Yeah, the pins are used for multiple things. That's why it does that. Some of them are part of the boot process and so on. So there you go. Now we can turn the soldering iron off. That is booted up. See if we can bring this over here, if this actually works, if it connects to Home Assistant and everything. Just a moment. There. Well, there you go. Can you see this? Sort of. I can bring you in with this one. So here are my breakers then, or switch power switches for these 4 outlets. So if you do, yes, it turns something on. If you turn on the right one, we don't know. So, and does this to all of them? Yeah, it does. That's pretty cool. See, they even have little LEDs on them, so you can see if that, yeah, that turns on the first one. That turns on the second one. That turns on the third one. That turns on the fourth one. So that should be good. The relays should be working. We'll try and see if we're also getting power out the other end. Can't imagine that we're not, but then again, you can't be too sure about these things. So let's try that too. I'm going to clean up a little bit here. There you go, like so. There, and we have a little test load. This will do. And power supply from my Dell Precision Workstation rack mount edition. Sure. If you plug a cable in here, nothing should happen right now because it is off. There, and this is for the NAS. So let's say I turn the NAS on. There. Ah! It worked. Lovely. I also checked the second one. There's very small chance that this wouldn't work as well. Yeah, that's working too. Great. Okay, so what do we have next? This, whatever is on, doesn't have a name on it, this one. That means that it is Bertil, the Excel machine. Since the other one are in pairs, the other two coming out of here are in pairs that have the same connector, right? And the other one has a regular power outlet on it, so that's how it is. There, connect that and turn Bertil on. Yes, very good. And one more, we can turn the soldering iron on and off maybe. Try and use that for the one that goes directly to an outlet, to a regular outlet here. Here. Plug that in like so. Like so. And then we turn our gaze to there. And then I turn on the extra outlet. Yes. It's all working. Magnificent. Magnificent indeed. Fantastic. That means that Dr. Pluring's relay box is now finished. I really only need to put the lid on this. But maybe I should leave the glue to cure and set for like another 12 hours or wait until tomorrow or something for doing that. But that means I also have to wait until tomorrow until actually implementing this. And a more efficient or impactful demonstration would be to hook this up to everything in the closet and turn on the NAS and turn on wait for it to boot up and then turn on the drive bay case, the case of only hard drives, and be tailing the log of the NAS and see that the hard drives show up and so on. But you can imagine that happening. It's the same deal. We turn relays on and off. That's what we do here. So that has been that. So part 3 is 45 minutes or an hour or so, 50 minutes, 45, 50 minutes or so, and that's about that. From Dr. Plurings Computer/Electronics Laboratorium for this time. We thank you so very much for watching here. Hello. White balance. You're not quite familiar with the term, or you have locked... there you go. We thank you so very much for watching. The mouse and I. See you next time, I suppose, for whatever I figure to do then. And cheerio.